Okay, I know this is just a test, but I really I want to see if this works. I'm going to give you a walk through this worksheet on linear regression using a calculator. I have a calculator app here, and hopefully you can see how the buttons work. So what we're going to do is we're going to enter some data into the calculator, but before we do, we're actually going to jump down to this step down here, okay? So the goal here is to enter the data into our calculator and have the calculator draw a best fit line for us so we can figure out if our data is strongly correlated to that line, meaning it gets really close to the line, or if it's really far away, or if it has absolutely no correlation or very little. So what we want to do first is turn the correlation coefficient on. So what we're going to do is first turn your calculator on. Notice where my mouse is going so that you can tell what buttons I'm pressing. You're going to press the second button, and then you're going to press 0. That opens up your catalog. And then you're going to, if you hit the letter D, which is right here where it says matrix, hit the letter D, it actually jumps you to D. And then just scroll down until you see diagnostics on there. And hit enter. And then hit enter again. And it turns the diagnostics on. So that's going to tell us the correlation coefficient. Now, if you don't have any idea what these words mean, that is okay. The main idea is when you get a data set, you're going to plug it in your calculator, and it's going to give you a line of best fit. So these are the steps to that. So we want to enter some data in, okay? So enter data, hit stat. Stat is right here. Hit stat, and you're going to go to edit. Edit is also right here. On the top, these top tabs, we're going to do edit. L1 is the independent variable, L2 is the dependent variable. So hit enter. So here's L1 and L2. So what we're going to do is we're going to go here, scroll down. We're going to use this real world example number 1, and I'll walk you through this one, okay? So let's get the calculator back up. So it says here, enter the data into the list using the graphing calculator. Let x equal the number of years after 2000. Now, x is always our independent variable. So, year after 2000. So, 1 year after 2000, 2 years after 2000, 3 years after 2000. So, we're going to do 1 year after 2000, 2 years after 2000, 3 years after 2000, and do it all the way through 2014. So, you should have 14 entries here. 4, 5. I'm going to pause it for a moment. Okay, so I've entered all those data points in all the way through 14 on this left side. Oops. Scroll back down. All right, so now we're going to do L2. You have to use your little arrow keys over. Here's L2. Now L2 is our Y values, so that's going to be revenue in millions. Okay, so for ease, we're just going to put in these numbers here, and that should be okay. So I'm going to enter those in. 148, hit enter, and 155, hit enter. Okay, and what we're doing is this correlates with 2001. I got 148 million in revenue, so 148 million revenue. I'm going to pause it, enter the data, and then we'll get. Okay, now since some of you may not have ever used a graphing calculator before, if I make a mistake, like here I enter 344 instead of 345, just simply push the arrow back, delete it, and then press the number you want. Or you could just press the number you want. It's control delete process. So I have a whole set of data now. So we're going to find the best fit line using the graphing calculator. Those instructions are listed on the previous page. So I'm going to go back to that previous page, just going to scroll up. Okay, and that's right here. Entering the data, we've done that. Now calculator stat. So we're going to do stat, calc4, a line of, this is a linear regression. That's L-I-N-R-E-G. Okay, so let's go to our calculator and see what that looks like. Okay, so we're going to go back to the beginning. So I hit second quit, that puts us back here. And I'm going to hit stat. And when it says calc right here, it's talking about this tab. Before, when we hit stat, we hit edit. Now we're going to go to calc. So just put your arrow over. Calc, it's right there. And we're looking for number 4, which is linear regression. Number 4, linear regression. So you can either hit the button number 4, or you can scroll down to number 4, whichever one works for you, and hit enter. And then what you're going to do is hit vars, vars, and it's going to be y vars, which is here at the top. It's another tab. Hit it over, hit function, enter, and then y1, and you're going to hit enter. Okay. Boom. So so what we're going to do is we're going to hit enter. It's going to compute a line of regression. So what this is y equals mx plus b. Instead of m, they used the letter a. That's okay, no big deal. For their slope, which is a, they have 13.97. Okay. For their y-intercept, 129, and then r2 and r squared and r. This is going to be your correlation factor, your correlation coefficient. Okay. It's very close to 1, which means all your data correlates pretty strongly. So if you haven't done so already, that's where this part comes in. What is the correlation coefficient? What does it mean? If I look at the graph of this, oh, looks like somebody already has this in the window. Yes, so this is our correlation graph. So they've already, the calculator's already inputted our line for us. So what we do is we'll hit zoom, and I want it to fit. So just go down until I see zoom fit. That's 0, so I can just press 0 as well, and it'll make the calculator do this best fit line for me. So here's my best fit line. My y-intercept, remember, that was at like 129. So that's why it looks like that, and then the slope is 13.9. So I rise up 13.9, and then I run over, rise over, run up 13.9, and rise over that much. Okay, so here we go. Correlation coefficient. Is it close to 1? That means the fit is very strong, and I could write that in, strong fit. If it's further away from 1 or -1, then the fit is weak. If the scatter plot appears random, then there is no or low correlation. Okay. If the correlation coefficient is positive, the slope will also be positive. And if the correlation coefficient is negative, the slope will also be negative. Okay. So that's that piece. And this right here, we often will need to interpret slope and y-intercept in the context of the problem. So you go with the topic of the data. For this topic, the real world example down here, it's the revenue in millions of the Baltimore Ravens. So that would be your topic. It asks what if it increases or decreases. And as you can tell by the graph that we've created, that's an increasing graph. Okay, so the revenues are going up. What's the slope? It has a slope of, well, 13.9, and the y units per x units. It's the revenue per year. How much money do they make per year? Okay, so that's what they're talking about. So state the best fit line using the graphing calculator, and all that would be is write this equation down. Write this equation down, filling in these variables, the a and the b. Y and x you can leave the same. You don't need to put any r's or anything in for that. State the correlation coefficient, describe the type of fit. The correlation coefficient would be here, your r, 0.99. So it would be a strong fit because it's very close to 1, all right, or -1. Interpret the slope in context of the problem using a complete sentence. So I would say, or I could say, as far as the slope goes, that the revenue per year increases about 13.9 million. About $13.9 million per year is about what they're increasing. And as you can see, that's close. See, this increases about 7 million, and this increases here from 55 to 172. It's about 17. So as you average all those together, your best fit line kind of gives you an idea of where it would land. All right, so the revenue per year increases about $13 million. and you could reword this in a different sentence. I'm kind of, like I said, this is my first attempt and I'm kind of rushing through it. But the revenue increased about $13 million for the Baltimore Ravens. Okay, so with that information, see if you can attempt the second world or the real world example on your own. To interpret the y-intercept basically tells you that's where you started your data. They started at about 129 million in the year 2000. Okay, so you could just write that in the year 2000. Team made revenue about $129 million. Okay, here's your model predict what the revenue will be in 2016, and all you do is you would essentially add the slope to that. So the revenue would go up about $13 million. So that would be what, 345 million plus 13 million. So it's about $358 million. Okay, so there you have it. I hope that's helpful to you, and I'll try to post this as soon as I can.